Welcome. On this video, we will discuss exponential decay. So let's get started. Now, under the introduction question, it says, in the same plane, we're going to be graphing the function 2 to the x and 4 to the x. And we're going to try to identify, is there anything that they have in common? And also, is there any difference between both functions? So let's graph 2 to the x and 4 to the x. And for that, we're going to go to Desmos. So here we have our functions in question. So here we have the red function is 2 to the x and the blue function is 4 to the x. And let's start with the similarities. So if we just take a look at the way that these graphs or these functions are behaving, just looking at the graphs, the first similarity that you might see is that they both seem to be intersecting at this point, 0, comma 1. So let's write that down. So at least for similarities, the first similarity that we can observe is that both functions, they share the point 0, comma 1. But why is it that they both have the point 0, comma 1? Like, what is the idea behind it? Why is it that they intersect both at 0, comma 1? Well, what exactly is this point telling me? This point is telling me that when x is 0, y has a value of 1. Well, let's go to our functions. If we go to the function 2 to the x and we go to the function 4 to the x, well, when x is 0, we're going to have a 0 as an exponent. So therefore, we're going to have 2 to the 0, which is exactly 1. That's the same idea here. We're going to have 4 to the 0, which is exactly 1. So therefore, they both have the point 0, comma 1. So regardless the base, when x is 0, you're always going to have an exponent of 0, and your outcome is always going to be 1. Because any number raised to the 0 exponent, it is always equivalent to 1. So that's one characteristic that all exponential functions, where the base is just an integer, have in common. They're always going to intersect at the point 0, comma 1. Now, what's another similarity that these both functions have in common? Well, we already discussed that they both intersect at this point. But another similarity is that both functions seem to be increasing in value. If you take a look at the way that the red function behaves, as we move into the right-hand side, the function increases, and the same goes for the blue. As we move into the right-hand side, the function is increasing as well. So perhaps that's a second similarity, that both functions, I'm just going to label them, are increasing functions. And I think that takes care of the similarities. Now, for the differences, what are some differences that these both functions have? Well, even though both functions are increasing, notice that the blue function seems to be increasing faster. Let's zoom out a little bit. Notice the blue function is going to be steeper, so therefore it is increasing at a faster rate. What is one way to notice this? Well, notice that in order for me to, at least in the blue function, in order for me to get to the value of 4, I'm exactly at x equals 1. And for the red function to still be at the value of 4, I'm actually at the value of 2, give and take. So notice that at least for the blue function, it only takes one value to get to 4, where the red function, it takes 2 values to get to the value of 4. That's one way for us to see, for us to just visualize the idea of when a function is increasing faster than the other. Let's take another point. Let's take a look at 12. So for 12, on the blue function, I only need a value of 1.79 to get to 12, where for the red function, it takes 3.58 in order to get close to 12. So therefore, the blue function, it is increasing faster than the red function. So let's just write that down. There's a big difference. So even though they both functions are increasing, the function 4 to the x increases faster, it's supposed to be an s, than 2 to the x. And that's a big difference. And that takes care of this question. Note that both functions are increasing functions. As a matter of fact, they're exponential increasing functions. They both have the point 0, 1, but the big difference is that the function 4 to the x, it's increasing faster than 2 to the x. And just to arrive to the same conclusion without looking at the graphs, the higher the base of the exponential, the faster it will increase. So notice that here 4 to the x, 4 is definitely higher than 2. They're both increasing to the x, they're both raised to the exponent of x, so therefore 4 to the x will increase faster than 2 to the x. Now, in the same plane, let's graph the function 2 to the negative x and 4 to the negative x. And still, let's try to identify what is it they have in common and what are some of their differences. So now we're not talking about a positive exponent, now we're talking about a negative exponent. So let's flip that. Let's make this into a negative. So we already saw that if the exponent was positive, then we have an increase in functions. But now notice that, let me just go back to it. This is when my exponent was positive. So if we change it to a negative exponent, notice that positive, it seems to be increasing. As we're moving from the left, going to the right, we have an increase in function. But when we change that to a negative, oops. But when we change that to a negative, notice that now my function, it's decreasing function. And the same goes with x. So let's change this 4 to the x. Notice that for the positive x, it's an increasing function. If we change that to a negative, let's change that to a negative now. Notice that it becomes a decreasing function now. So now that we have established that idea, let's go back to the lesson and let's answer the question, what are some similarities and some differences that both functions have? Well, for similarities, we already established that both functions are decreasing functions. Now, is there anything else that they have in common? Well, notice that they still go through the point 0, 1. So both functions they share the point 0, 1. And that is because of the same idea. Well, if we take a look at 2 to the negative x and 4 to the negative x, if we substitute the value of x for 0, we still get 2 to the negative 0, 4 to the negative 0, and it just doesn't make sense for us to call it negative 0. So now this becomes 2 to the 0, oops, and 4 to the 0. And any value raised to a 0 exponent, it's always going to be 1. So now this just becomes 1, regardless. So they still have the point 0, 1 in common. So that takes care of the similarities. Since they have a negative exponent, now they are decreasing, but they still share the point 0, 1. So now what are some differences now? Let's see. If we take a look at our graphs, notice that the blue function seems to be decreasing faster than the red function. And the blue function is represented by 4 to the negative x. And the red function is represented by 2 to the negative x. And that seems to be the difference between both of them. It's just the rate that the functions are decreasing. So let's write that down. So now we can say that there's a big difference. And that difference is that the function 4 to the negative x decreases faster than 2 to the negative x. And we'll explain algebraically why that is true. But at least this seems to be the difference between both of them. It's just the rate that they both are decreasing. So, how does the negative in the exponent affect the behavior of the function? Because notice that we were talking essentially about the same graph or the same function, 2 to the x and 4 to the x. So when we have a positive exponent, it seems that both of our functions were increasing. And notice that by changing the exponent to a negative, we made it into a decreasing function. So it seems like by changing the sign of the exponent, which in this case was from positive to negative, all we did, we changed the direction of the function. And what I mean by changing the direction of the function was that if it was positive, then we were increasing. Then by changing it to negative, now we are decreasing. So now this raised the question, well, if I have a negative exponent, do we always end up with a decreasing function? Well, let's take a look. Now, still on the same grid, or going back to our Desmos activities, now we're going to graph a fraction with a negative exponent. And let's see if that is true. Because right now our hypothesis is that, or at least our observation says that if we have a positive exponent, then we have an increasing function. And if we have a negative exponent, we have a decreasing function. Well, does that still hold true for fractions? So let's go to our decimal activity and see. So here we have the function of 1/3 to the negative x and 1/5 to the negative x. So let's graph it. Right now our hypothesis is saying that, boy, if you have a negative exponent, it is decreasing. Well, let's see if that is true. We end up with the positive, or we end up with the increasing function. And the same is going to go for 1/5. 1/5 to the negative x. We end up with an increasing function. So perhaps our observation was not completely right. And that's one observation that I want to make. That not because you have a negative exponent, that indicates that you're going to have a decreasing function. But why is it that when we have a negative exponent, sometimes it is increasing and sometimes it is decreasing? Well, let's show that. But before we show that, let's answer this question. So does the example back up the claim that we did in example 1, which it was a negative exponent indicates a decreasing function? Well, in this case, it is not. So not all negative exponents functions mean we have a decreasing function. But why is that? Well, let's take a look at the examples that we have discussed in this lesson. So we started with positive 2x and positive 4x. So let's show that. So we know that it's increasing under the function 2x, 4x, and also 1/3 of negative x and 1/5 of negative x. And we have shown that decreasing, at least for the examples that we have worked for today, we have shown that the functions 2 to the negative x and 4 to the negative x are decreasing. But we want to just concentrate on those that have a negative exponent. So we're not going to discuss too much about 2 to the negative, 2 to the positive x and 4 to the positive x. But let's concentrate on those that have a negative exponent, because that's pretty much what we want to show. So let's see. So when do we have an increase in a decreasing function? Well, what does it really mean for us to have a negative exponent? So what would happen? So what would happen if we switch this expression What would happen if we switch the expression 1/3 to the negative x as a positive exponent? Well, recall that to switch the sign of an exponent, what we can do is switch the sign and take the reciprocal of the base. So if we want to rewrite this expression as a positive exponent, this is just going to be the reciprocal, which in this case is going to be 3/1, all to the positive x. Well, what does this really is? Well, this is exactly 3 to the x. So now notice that my base is higher than 1. So we were essentially graphing the function 3 to the x when we were graphing 1/3 to the negative x. And notice that my base is higher than 1, so therefore my exponential, it's an increasing function. So the same is going to go for this 1/5 to the negative x, because if we try to rewrite this function or this expression as a positive exponent, well, this is equivalent to taking the reciprocal of the base, which the reciprocal is going to be 5/1, but now we can change the sign of the function. And 5/1 is exactly just 5, so 5 to the x. So notice that we were essentially, when we were looking at the function 1/5 to the negative x, we were essentially just looking at 5 to the x. So notice that when my base it's higher than 1 with a positive exponent, my function it's increasing. It was going to be an increasing or an exponential growth. But the same ideas can apply to those that are decreasing. Because notice that we have this function, it is a negative exponent, and we try to write it as a positive exponent. Same idea. Let's take a look at the base and find the reciprocal. Well, the reciprocal for 2 is going to be 1/2 with the positive exponent. So now notice that we're graphing 1/2 to the positive x. And the same goes for the other function. 4 to the negative x, if we want to write as a positive exponent, is going to be 1/4 to the x. So when we were looking at the function 2 to the negative x, we were really looking at the function of 1/2 to the positive x. And we were looking at the function of 4 to the negative x, we were looking into the function of 1/4 to the positive x. So now notice that we always going to have an increasing function if the base is higher than 1. And what do I mean by base? Well, base is the base of the exponent, which in this case, the base for the expression is 2, the base for the expression is 4, the base of this expression is 3, the base of this expression is 5. And when do we have a decreasing function? Well, we have a decreasing function if the base is between 0 and 1. So in that case, if x is between, well, I shouldn't call it x. Let me call it a different value, because x, it can get confused with the exponent there. Let's say that the base, we're just going to represent it with the letter b. If the b is between 0 and positive 1, not including 0, not including 1. So let me just, where again, b is the base. And this is very important for us to understand. So not because we have a negative exponent, we're always going to think about having a decreasing function. Well, when we try to write everything in positive exponents, once your exponent is positive and your base it is still higher than 1, then we're going to take a look at it when we're going to label that function as an increasing or an exponential growth function. And if my base is between 0 and 1, once my exponent is being written out as a positive exponent, then we can label that as a decreasing or an exponential decay function, since we're talking about exponential functions. And this is the summary for today's lesson. Make sure that you do understand both cases. And with this, we conclude our lesson for exponential decay.